All right. So test on next Wednesday. Okay. Now, today we're going to prove inverses, right? Now, can you take this equation and tell me all this information? Equation information.
I need this one.
No. Negative? Just watch me do it because you'll look up NBA stats or something. Okay, so look at this. I got this graph over here on the right. And I'm going to answer these questions. What is the y-intercept? So you click the y-axis, and what do I got? 0, -11, right? Now you tell me, where does this graph cross the x-axis? Oh wait, hold on, I missed one. Vertex. What's the vertex? Where does it change direction at the top? -3, -2, right? Now, where does this cross the x-axis? Where does it cross this line? It doesn't. It's not 0, because 0 would actually be touching 0. It's actually no solution. So what are the x-intercepts? You can put none, nada, nunya. Okay. Now, we already said domain goes forever left, forever right. That's all real numbers. And then the range. Now, this is where it's a little different. This is not going up forever, it's going down forever. So do I put less than or greater than if it's going down? Less than. And since it's range, I got to put y. So it's y less than or equal to, and then which of these numbers am I going to put? What's the y value here? -2. Y is less than or equal to -2. So basically, this graph, if I can draw correctly, is like 3 to the left, 2 down, and it's going down. It's going down for real. Okay. Write that down. We got some notes. Did that? Steve? Steve? Steve, did it? No? Yeah, Steve. Want to smash a banana before. Is that you? No. Oh. Look, it's Dr. Pepper on. All right. We'll make this short. Okay. All right. So to verify inverse functions, okay, if you have two tables, all you got to do to tell if the two tables of inverse functions is you want to see if the tables are switching x and y. Okay, it's super easy. Just look at it. So if I switch this, do I get this? So if I switch 1 and -3, do I get -3, 1? Yes. If I switch 2 and -2, do I get -2, 2? Yes. If I switch 3 and -1, do I get -1, 3? Yes. Are these inverses? Yes. All right, if I switch -7 and 0, 0, 1? No. All you need is one mess up, and it's no. So that's super easy, right? With tables, you're just seeing if it perfectly all the way down is inverted. Okay, that's why it's an inverse. Oh, I guess I should have put it down here. Are they inverses? Yes. Are they inverses? No. All right, that's one of them. All right, then we got to talk about graphs. Everyone good on the tables? Okay, graphs. Two graphs are graphs of inverses if they reflect or are symmetrical across the diagonal line y equals x. Now, everybody, you got to know how to make y equals x. If you're at the center and you go up one, right one, up one, right one, like if you're on the grid and it's going this diagonal line is y equals x. Okay, that thing. No, that's just the line that it needs to reflect over. So like, for example, if there's something over here, whatever, it's got to reflect over here. So everything's going to kind of like be a mirror image over this diagonal line. So let's just take a look over here. We want to verify if these two graphs are inverses. Now, real quick, you could do this the table way by turning these points into tables and seeing if they flip over. You could turn it into a table problem if you wanted to. But let's see here. Do the lines look like they would reflect over y equals x? So let me take these points. So what is this, -3? And this point, okay, I'm kind of just taking a look at it. Does that look like it reflects across this diagonal line? Does it look the same on the top and the bottom? It does. It looks like it. Now, the way you would know for sure is this point is -3, 0. This point is 0, 4. If you flip them around, do you get 0, -3? And the answer is no. 0, 4, do you get 4, 0? The answer is no. Even though it looks like it, if you take these points and you flip the points, it has to match perfectly. So this is actually a no. No, sir. No. Okay. Barely. So this is actually a tricky question because it did look like it. It did look like it. So check the points. Write out the points. Flip them around. See if the new points are on the other graph. After this, they'll be pretty quick. Let's look at these two. Let's look at the vertex. Let's just like write this vertex point. This vertex point is 1, 2, 3, -4. 1, 2, 3, 4. -4, 4. If I flip this around, it should be 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. And you guess what? That is flipped around. These 2 points are flipped around. 0, 6. Flip it around. Do we get 6, 0? Yes, we do. So when we flip the points, yes, they are inverted. Okay? So that's the second thing we needed to learn today. If you have graphs, turn them into points, flip them around, see if they match. Now, okay, what I did up here is what you're doing on the back. So I'm going to show you the whole thing. Okay, so flip it over. I just want you to see what they did was they took 2 points like I did already up here, -3, 0, 0, 4, flipped it around, 0, -3, 4, 0. They don't match here. That's a no, so put no. Okay, I know I didn't make this, but it's across 2 different pages. That's kind of crazy. -4, 4, 0, 6. 4, -4, 6, 0. We said that does match. So it's a yes. Okay. Last thing. This is the most important part on the back side of the notes because this is potentially the most difficult part. Potentially. You got to be able to algebraically prove 2 functions are inverses. Okay? Is everyone caught up? Got like stuff in my throat. Okay, check it out. Very important. 2 equations are inverses if, when you find the inverse of one equation, you end up with the other equation. Okay? So if I take the inverse of this first one, it better end up looking like this one. Then it's an inverse. I mean, kind of obvious, right? So let me remind you of the steps of finding an inverse, okay? F of x, it's really a y. You switch x and y. So you get x equals 2y plus 3. Now you need to solve for y. To get rid of that loner plus 3, you subtract 3, and you might already notice that it isn't looking like the other one up here. Your last step is to get rid of that 2 by dividing, right? Divide by 2, divide by 2. And then you write it as an inverse, x minus 3 over 2. Does this match this? No. Right? That little plus sign, that's a minus sign. These do not match. So down here, you're going to put no way. Okay. After this next one. So let's do it again. This is really y. Switch x and y. So you get x equals y plus 4 squared minus 5. You got to do each step in order, okay? So the loner, the minus 5, goes first by adding 5, adding 5. X plus 5 equals y plus 4 squared. So far, it kind of looks like it could match. How do I get rid of the squared first? Opposite of square is square root. Square root of all of it. So far, looks good. And then how do I get rid of this plus 4? Opposite of plus 4? Minus 4 after the square root. So my inverse function is square root. X plus 5, stop. Minus 4 goes after it. Does that match this? What do y'all think? Yes, it has to match perfectly. So are they inverses? Yes, sir. Okay, I got a little one-sided assignment for you on this. If you need to still correct a quiz or a test, I'm going to have you do that first. Please. Have a minute. I know he's going to want to go. He's going to be like,
What?
you got to go?
No.
Okay. Well, he's going to want to go. Okay, but 7 minutes, you know?